Ah, okay. Sorry, guys, we were muted. I just now saw that. So let me know how the audio levels are, and let's press on. We're going to start with digital atmosphere and take a look at the surface chart. So let me erase this and get some new data up and going. Okay, so we can see northerly flow across much of the U.S., the central U.S. right there. And we've got 50s there in the Texas Panhandle and a lot of 50s in Oklahoma. And down here in our part of Texas, we're getting gusts. And I can add those to the plots. I can just go into this menu here, go to station plots, and add gusts. Where is that? Yeah, it's right there. Okay, so those will appear just to the right of the plots. And you can see we've got a lot of gusts over 30 knots. So we're talking about 35 miles per hour. And the strongest that I'm seeing is probably right here in the Dallas area. So our fronts have moved well to the east, probably to Louisiana and Mississippi. I would probably go with maybe a frontal location somewhere out here. Could be back here. It's hard to tell because the air mass is very disrupted by an outflow boundary. So you see that right there. That looks like outflow from a big meso high, which in turn is being caused by a big MCS moving through Louisiana there. So the cold front is hidden in there somewhere. And let's see, further up north, we've got a continuation of the front up into the Ohio River Valley area. And just up here north of western Tennessee here, I can see maybe what looks like a warm front, maybe in this area right there around Blytheville, Arkansas. Okay, so let's head to the charts. There you go, quite a bit of shower activity. Mississippi pretty much covered there, and there's our big MCS. So, cold air mass driving south as a big wedge and helping to create a lot of this activity. The SPC's convective outlooks just had a slight risk in the western Gulf Coast, and marginal all the way up to Illinois and Indiana there. So here's our 250 millibar chart. And you can see we've got a trough across the central U.S., a very broad, long wave trough, and then smaller scale synoptic troughs, probably like that right there. Looks like there's a ridge across Illinois and into Kentucky, and probably another ridge up in Montana and Alberta there. Pretty similar picture there at 500 millibars. Kind of a deep trough here in Kansas and the Texas Panhandle. And then down at 700 millibars, we start to see some of the surface system here, and that shows up actually better at 850. So this is charts from this morning, and we can see the cyclonic flow around Wichita, Kansas. So there's our 850 millibar low. The location of the fronts, fairly easy to pick out right there. There's our 850 front from Oklahoma City to about Roswell. And then I think we have our 850 warm front right there from the Ozarks into around Nashville. There's all the moisture we had surging northward earlier. And we've got a much different picture right now, as you saw there on the surface chart. And things have really pushed east here. Large anvil shield covering the lower Mississippi Valley. Some of these tops here are well up to 55,000 feet. I saw that on a few of the East Texas storms. They were pushing up to 55. And a lot of the anvil canopy is topping out at about 36 to 38,000. So quite a deep system there, and you can see the cold core, or I should say some of this is cold core activity. You can see this cumulus up here in the Central Plains. There's a little bit of vertical development in this stuff. So this is basically warm temperatures near the ground, very cold temperatures aloft, and that difference in temperature gives us a unstable profile. Okay. Then we'll head to the isobars and thickness, and that's probably a good place to stop. Let me check the stream and see how things are going in chat. Okay, let's see here. We've got Andrew. First one on, as usual. And Eddie W. is here. Ryan Toomey's from hot and steamy South Florida. Mike Wan missed the past couple of webcasts, but caught the reruns. Excellent. And Ryan is waiting for the cold front, waiting anxiously for it to push south. Fun with Tech is here, and Greg Kerner, Mike Estwick, and Megan John, and Mick, Kevin McKinney, Trevor Parker is here. Mike Estwick digging the music there. Robert Archer getting ready for heavy rain there in Indiana. Yeah, indeed. You can see the system right there poised over Arkansas and Louisiana. That's going to push up to Kentucky and Tennessee. And Indiana is going to be in the deformation zone area to the north. So kind of an extended window for shower activity as that shield slowly pushes by Indiana and Illinois. Brett Dean says it cooled way down in southern Jersey to 59, expecting 3 inches on Friday. Needing the rain there. Ryan seeing epic flooding going on around Missouri and Arkansas, wondering if they're going to get a break. Okay, Robert and Megan mentioning the levels look good. Will OTC checking in, recovering from the trip down to Texas for the Canton tornado. I can imagine that was quite the event there. And I don't know if you were actually chasing the... let me check here. Yeah, I don't know if you were actually on the storm or doing damage survey or not. You have to let me know. But yeah, chasing East Texas, that's very tough. And I've tried that a few times and have never gotten any good footage east of I-35, really. Okay, Brett Dean asking why Barb's was blue and red on the bottom of the wind barbs. I think that was way back when I was drawing on these maps. This is going to be a cold front, and since this is hollow, this signifies an upper front. And then sometimes I'll draw the warm front, and those will have pips on the end, rounded pips. And sometimes I get lazy and just use the wrong color, so don't worry about that too much. Okay, Greg Schall's preparing for a weather safety day at his museum, May 13th in Milwaukee. So any of you in the Milwaukee area, Wisconsin, check that out. Maybe Greg will let us know which museum that is, and I'll try to make mention of that on here. And Megan John mentioning vorticity advection. Melody Loves Jesus is checking in, and Michael Burrell. Dorothy Tornado made it in, and Andrew asking about deformation zones. Yeah, I think we'll have to do a module on synoptic storms, and I got hold of a lot of my references from the 90s and 00s, and I think those will probably be a good place to start. I can probably build some modules with some of that stuff, and we can discuss some of those basics of extratropical storms. Brett Dean saying to hit the like button. Yes, please definitely do that. And Patreon. Yes, Patreon, if you can always appreciate donations. And I wanted to mention, I wanted to thank some, let me see if I can bring this up here real quick. Yeah, I did receive some Patreon donations, and I'll have to pass that along and make mention of that probably in tomorrow's webcast. So let's press on here. Okay, low pressure over Louisiana and Arkansas. So we've got a low pressure area extending out towards the Rio Grande Valley. Rio Grande. I have problems with that. Rio Grande. I think that's... Okay. Warm front out to Tennessee and North Carolina there. So the cold air mass lurking up to the north in the northern plains and filling in behind that surface system here. And you can see that the tropical moisture is confined to this corridor right here. So the gradient at the surface favoring flow mostly across Mississippi and Alabama at this hour. Okay, we'll take a quick look at Skew-T's here. This is the current Skew-T at Fort Worth, showing a bit of capping aloft. And when we go into the northern plains to North Platte, we pick up a little bit of that cooler air, and it looks like it is concentrated mostly in the mid-levels. So you can see we have these very steep lapse rates right in here, a little bit of moisture, and that'll give us some of that high-based convection we're seeing there. Very strong winds here, 110 knots there at North Platte. And there's Rapid City right there. Warm air in the upper levels, but in the mid-levels, a bit of cold air right there. And also an inverted V right there, so that favors a little bit of mid-level convection right there. Okay, I wanted to take a look at the radar real quick. We had these storms blow through very quickly in East Texas, and they started out in the Dallas-Fort Worth area about 1 or 2 o'clock, pushed rapidly to the southeast, and now we find them from about Houston to Alexandria and Baton Rouge, Louisiana. And this is the Lake Charles radar, and you can see we've got quite a bit of flash flood warnings out for these storms here. Don't see too many severe weather warnings. In fact, I don't see any. Let's see, where do we have to go to find severe weather watches? Well, none of those, so that's kind of a blessing in disguise there, but we do have a few isolated storms out ahead of the line. And quite often, these are the ones we have to watch here. You can see they're isolated. They have access to the moisture supply down to the south. And a lot of times, this part of the air mass here is very warm. And it's in the middle of the moisture axis right there like that. So with that close proximity to the moisture to the south, this can be an area where we can see storms really get going. Then back here we have the main squall line. And let's take a quick look at maybe a cross section. So I'm going to draw a line through the squall line here near Beaumont. And there it is right there, just kind of a garden variety squall line with tops up to about 43,000. And the most important thing that you can see here is the higher reflectivities, the yellows and reds. Those are concentrated very close to the surface. That's very important when we're forecasting a situation like this. When those start coming up in the higher levels of the storm, that means trouble. And maybe I can show an example of this in one of the stronger storms. Great, I'm losing my voice. Well, let's hope it holds here, and I'll try to get through this the best I can. Let me go out to the storm here, north of Lafayette. And I'll try to drag it through here and see what we get. Higher reflectivities, still pretty low, but the reds are coming up to about 16,000 right here, so we'll look around a little bit more and see what we come up with. I'll try north of Lake Charles here off the left side of the map. And here, yeah, we can see some of these reds kind of suspended aloft. And this is kind of what we call overhang, especially if it's over kind of a clear area like here, like this part. So let me show you an example of a tornado day, and we'll look at the opposite type of situation. And we'll go to the May 31st of 2013 storm, the El Reno. Let's do that one here. Okay, let's see. What time was the tornado? I think that was about 23 maybe. Okay, so radar data here on a very severe storm, the El Reno storm. You can see the big tornado warning in effect for that. And let me get this squared away. I've got to figure out the correct time to pull up. Yeah, I think that's going to be it right there. Okay, so this actually here is the debris cloud from the tornado. Very large debris cloud, and this is the main part of the supercell here up to the north. So if we do a cross-section on this storm, let's do that real quick from north to south. And there's the El Reno storm with very prominent overhang right there. So do you see the overhang area? See how the reds are coming up to 40 to almost 50,000 feet here? Yeah, all of this here is the overhang. And what this is signifying is the inflow coming into the north and entering the mesocyclone here and descending into the updraft. And so we get very rapid upward motion on these updrafts. Remember, it's very unstable. And most of the precipitation particles and the graupel and ice and all that, they fall out at very high levels within the clouds. So we end up with kind of a situation like that. You can see the purples all the way up to 35,000. So yeah, that was quite an event there. And let me back this up a little bit and we'll take a look at one more frame. I'm going to go to 2300 and look at this a little bit earlier in the tornado's life cycle. Now my memory is kind of fuzzy what exactly was happening at 6 o'clock, but let me look at the velocity real quick. Okay, so there's our circulation right there. Okay, so let me do a cross-section of that storm here. And this very prominently shows the beware, the bounded weak echo region. So that's it right there. So that's kind of a notch extending upward into the overhang. So you see all that's the overhang right there. So that's the updraft, probably 150 mile an hour updraft, going straight up, and you can see the storm is topping out there at about 60,000 feet. And that's higher than the level the Concorde used to fly at. Concorde usually flew at about 53 to 54,000. Pretty amazing there. And just for the heck of it, let me bring up the velocity. I want to see what that looks like. Okay, let's see. What are we seeing here? Well, we're looking to the east. And the blues, those are going to be motion toward the radar. So yeah, this is flow into the screen. And then the flow coming out of the screen is out here. So this is the main mesocyclone up here, and then down lower we have the tornadic circulations. And then I'll show you one more thing real quick before we move on. I don't think I've ever showed a volumetric look at the storm, but let me do that real quick. Volumetric is basically looking at the storm in 3D. And let me fix this so it looks right. Okay, so there's the storm, the El Reno storm. All the action has taken place right under here. And underneath there you can kind of see the beware. So the air is coming in from the south and then going up into that part of the storm right there. And we can probably cut that away a little bit. Let me use this tool here. I'll kind of chisel away and peel back some of the lower reflectivity values. Let me switch this over to isosurface, and there we go. Okay, so when we have this over in the green, we're looking at lower velocities, or lower reflectivities. So a lot of rain is showing up here. This is not the cloud. This is actually precipitation and hail and ice and all that. So I'm going to bring this up and show some of the heavier precipitation. Can't quite see the beware under there. It's kind of lost in. I think I would have to change the illumination a little bit and play around with that. Let me see if there's anything I can do here real quick. Yeah, there we go. So now do you see it under there, the beware? See, this is the south side of the storm here. So the inflow going up like that into the beware. So now we're showing some of the heavier reflectivities. And this is probably going to be our wet hail. This is the highest reflectivities. This is going to be wet hail almost entirely here. So there you go. There's some neat stuff to look at, and maybe on our next big severe weather outbreak, we'll play around with a little bit of that. Okay, it's time to head into the forecast here. And we'll start out with a quick look at the dynamics. Okay, sorry about that. I'm trying to get everything on the screen correctly. Okay, so there's the current picture, and this is showing the big trough across Kansas and Oklahoma there. A couple of waves moving through the flow right there. And a little bit of disruption in here. You can see this splotchy appearance in this region right there, and that's probably due to convective feedback and sampling of, like, the grids are kind of cutting into some of the storm activity here, and that's kind of messing up the upper level patterns. But in any case, the flow is pretty much channeled. So you can see the polar front jet is like that. There's the channeled areas right there, and this is the convective areas over Louisiana and Mississippi. So over the next couple of days, we'll just see the trough kind of descend into Arkansas and Oklahoma. We'll probably have some cold core convection out over the Memphis area tomorrow. And most of the rest of the precip will be pushing out towards the east coast. And then northerly flow coming back in behind and kicking some cool air southward from Canada. Okay, quick look at the mesoscale model. So we'll take a look at the 3 kilometer NAM. And this is showing us that overnight we're going to see the squall line kind of just push out into the Gulf. Looks relatively quiet there in Alabama and Georgia overnight. A little bit of shower activity right there around Columbus. There's the surface low right there in Missouri. And then by the time we do the webcast tomorrow night, low pressure in Tennessee right there. You can see the deformation zone up to the north of there. And it looks like a little bit of a MCS regenerates over Georgia and Tennessee. I'm not too sure that the elements are going to be there for convective, for severe weather. Let me take a look and see what the fields are showing here. I'll zoom in on the southeast U.S. and look at some of the severe weather parameters. And one that I like to look at is the significant tornado parameter. And this summarizes some of the more important parameters that we need for supercells, which is a low LCL, high bulk shears, high helicity, storm relative helicities, and high CAPE. Okay, I'm trying to get this working. It kind of defaulted over to Texas, and okay, I think it's working now. So let's take a quick look at what the significant tornado parameter has for Georgia tomorrow. Okay, 1518Z, we're pouring on the heating. So we're starting to see some values coming up in Georgia. And there you go. Looks like we get some values of about 2 to 3 around the Atlanta area. So maybe supporting a little bit of threshold severe weather activity. When we're in the 1.5 to 2.5 range like that right there, I'm probably thinking mostly just severe storms, strong thunderstorms, nothing too severe. So let's take a look at this air mass real quick and see what the ingredients look like, just, at a glance. Okay, so what do we got here? Do we have good CAPE? Well, sort of. We've got some steep lapse rates in the mid-levels right there. We've definitely got some good dew points in place. We don't have much of a cap here, so we're going to see probably some extensive initiation, just clusters of storms rather than isolated storms. So that's going to kind of work against widespread severe weather. We do have a little bit of storm relative helicity here. See the 0-kilometer wind vector right there out of the southeast at 10, and then it becomes out of the southwest at 35. So that's some good shear right there. So we can't completely rule out tornadoes there in the Atlanta area tomorrow. So let me take a quick look at what SPC is showing for our Day 2 outlook. And they've got a slight risk a little bit east of there. So a little bit of discrepancy there. So it could be that maybe SPC is focusing on activity after dark. That could explain some of that. So that's about all I know just based on that quick run through of what I'm seeing here. So let's move on to the GFS here and see what we got for the rest of the week. Okay, for tomorrow night, when we do the webcast tomorrow night, let's see here. Is tomorrow Friday? No, okay. Sorry, I'm a little bit off there. Okay, Thursday evening, tomorrow's webcast. Low pressure out over the Louisville area, and it looks like the main bear clinic zone is going to be in Georgia. So there's the setup of the fronts, and I think maybe Georgia will have a little bit of potential for some severe weather unless everything just kind of outruns. You know, if we get a big cluster of storms going up earlier in the day and they bolt eastward, then yeah, maybe we could find them out in South Carolina by late afternoon. But anyway, I'm just kind of speculating. Okay, then for Friday, we'll see things move northeast out into the New England area. There's the warm front right there in Massachusetts. Cold front along the east coast right there, and then an occlusion back out over Ohio there. High pressure across Texas. And this is the area where we're starting to set up return flow. Not quite tapping the Gulf yet, so the weekend is going to be kind of dry initially. So there's Saturday, kind of a mild, sunny day. Things going downhill in Nevada and California here. You can see we got a 540 decameter cold pool. Pretty strong surface low there in Nevada. And that looks to be the setup for fronts. One of my phones just made a noise. Okay. So, for Sunday, that system will be moving across the Rockies. Looks like a cold pool across Southern California, so it may be kind of an interesting day there in Los Angeles and San Diego. Maybe some showers over the mountains. Some spectacular cumulus clouds building up during the afternoon. And then for Monday, looks like the system kind of stalls out in the Rockies. Return flow definitely in place in Texas, and I think the dry line will become active starting around this time, maybe around Roswell and Clayton. Then going up to Tuesday afternoon, kind of the same deal, more moisture in place, and it looks like the front is starting to emerge. So it looks like rain chances will go up, and if we have warm enough temperatures and decent enough moisture, we may have some severe weather there in the Panhandle. Then for Wednesday, the system ejects northeastward. So there's roughly what the fronts look like, and probably a little bit of storm organization there in Kansas and Nebraska. And the system just kind of spins around there on Thursday, just continued precip chances. And then for Friday, things move into the southeast U.S. So probably some severe weather potential there on Friday the 12th. And then I'll shift up the coast into Saturday the 13th there. Looks like a polar ridge kind of noses in from a big 1036 millibar high over northern Manitoba. Very strong Hudson Bay vortex pattern, and that's really interfering quite a bit with chase potential. I'm sure the chasers are not happy with this pattern. See this big high just kind of covering most of the central U.S.? That's definitely not conducive for chasing, and I think probably a lot of the better activity is going to be later in the month. Okay, so not much after that, just looks like one more outbreak around the 17th. And then I don't see anything else of interest right there. It just looks kind of like a quiet weather pattern. Okay. I think that's about all I got there. Let me just take a quick look at the chat there. Wow, we got 35 people in here. Let me get my levels real quick here. Okay. All right, I'm just reading the chat real quick, catching up on any last-minute messages. A good model for precipitable water values. You can just use the GFS there on Pivotal Weather. Okay, that's about all I got for tonight, so we'll see you all tomorrow. Take care.